Random variable. In this video, I will talk about what is a random variable and what types of random variables are, and we're going to learn what is a probability distribution. So a random variable, a variable which is usually represented by a capital letters X, that has these two properties. It has a single numerical value, and that value is determined by chance for each outcome of an experiment, right? So it's a variable which has two characteristics. Number one, it has a single numerical value, right? And the second one, its value is determined by chance for each outcome of an experiment. You will better understand this idea when I give an example. So let's see an example. Let us suppose the experiment is we flip a coin 2 times, and the variable of interest is mentioned here is X, and we want to observe how many times the coin lands on heads. So if you remember from our previous discussion, that when you flip a coin 2 times, these are all possible outcomes. Heads, heads, tail, tail, heads, tail, or tail, head. These are all possible outcomes. And I hope you remember this is called the sample space, right? Now we want to find out we want to see how many times the coin lands on heads, right? So this is the situation in which the coin lands on 0 time on heads. These are the two situations in which the coin lands 1 time on head, right? And this is the situation in which the coin lands 2 times on heads, right? So what are the possible values? The possible values are 0, 1, and 2. So I can have any of these values. I can have a 0 time the coin lands on head, 1 time, or a 2 time. And this value is purely determined by chance. Such a variable is called a random variable. Take another example. Let us suppose we bought a pack of 5 light bulbs, and the variable of interest in this situation is the number of defective light bulbs. You went to a shop and you bought a pack of 5 light bulbs, and you want to see how many bulbs out of these 5 bulbs are defective. What you are hoping actually that none of them is defective, but what are the possible values? You can have 0 defective light bulb. That's what you're hoping for. You can have 1 defective. You have 2, 3, 4, or 5. All 5 of them are defective, and probably that's the only time you will go to that shop. You will never go to that shop again, okay? So these are all possible values. So this variable y can have any one of these these are numbers, numerical value, and these value are purely determined by chance. What is going to be that number? You can't tell. Such a variable is called a random variable. Let's say you are a police officer and you went to your police station, and in the morning you're sitting. You can't tell me how many car thefts will be reported today. You can't tell me at the beginning of the day. You don't know. But what you know, that it will have a single numerical value, and that value will be purely determined by chance. What is going to be that value? We don't know. But what we know, it will have a single numerical value. Okay. So such a variable is called a random variable. I have discussed some examples in which the situation that we have a random variable. Let's take an example in a situation where we can't have a random variable. For example, let's say I randomly select a student in my class, and I see the color of the eyes of the student in my class. The color of the eye of a randomly selected student in my class. That is not a random variable. The reason I ask you to pause this video and think about it, why it's not random. Primarily, this is not random because it don't have a numerical value. The color is not a number. It has to be a numerical value. So for this reason, this is not a random variable. The color of the randomly selected student, the color of the eye of the randomly selected student in my class is not a random variable. Now we see discrete and continuous random variable. These are the two flavors, you can say, that random variable comes in these two flavors. One is called a discrete random variable, and I hope you already have the idea what is a discrete variable. We have learned this in chapter number 2. A discrete variable is a variable which can have distinct values, which are separate from one another. So discrete random variable can either have a finite number of values or a countable number of values, where the word countable, this is a technical word, where the word countable refer to the fact that these might be infinite number of many values, but they result from a counting process. This is important. They result from a counting process, right? It's a counting process. You get this value as a result of the counting process. You can count them. The example is the number of bad checks drawn on an upright bank on a day selected at random. How many bad checks will be drawn on a randomly selected day? We don't know. But what we know, it will be a number, and that number will be purely determined. That number will be purely determined by chance. So such a variable is called a discrete random variable. How many students will get admission in the next semester? In the next semester in the Berkeley College? We don't know. But what we know, right now we don't know, but what we know that it will be a number, and that number is purely determined by chance. So such a variable is called the random variable, and on the top of that, it's a discrete random variable. Why? Because the data comes to you as a process of counting. So you can count them. So let's see now what is a continuous random variable. I hope you already know what is the continuous variable. A variable whose values results as a process of measurement. You get the data as a process of measurement, and they can have infinitely many possible values, and those values can be associated with measurement on a continuous scale without gap or without interruption. For example, the time taken to get out of the checkout lane of a food shop on a randomly selected day of the week. You don't know how much time it will take to get out of the checkout lane. You don't know, but what you know, it will be a number, and that number will be purely determined by chance. So this is an example of a continuous random variable. So remember, random variable comes in two flavors. One is called a discrete random variable, and the other one is called a continuous random variable. If the value of the random variable comes to you as a process of counting, it's a discrete random variable. And if the value of the random variable comes to you as a process of measurement, it's a continuous random variable. Now let's see what is a probability distribution, right? When I first saw this topic, when I was learning, this seems to be a very horrible topic. The title is very, very, very hard to understand, but the idea is very simple. When I give an example, you will really think about this and say, this is what it is. What is a probability distribution? It's a description. It's simply a description that gives the probability of each value of the random variable, and this description is often expressed in the form of a graph, a table, or a formula. And also it's called a probability mass function, PMF. Okay. So probability distribution, I will give you an example and then you will understand better. Let's see what I'm trying to say. Let's say you flip a coin 2 times. A variable of interest might be the number of heads, say a variable X. Let's say what I'm talking about. You flip a coin 2 times. I already told you in my previous example, you flip a coin 2 times and the sample space was heads, right? Tail. We have heads, tail, and the tail heads, right? These are all possible outcomes. And our variable of interest is how many times our coin lands on heads. Let's make a table here. Let's make a table here, right? Here I have the random variable X, and here I have the probability of X. Let's make a table, probability of X, right? Look at this table. Now, what are the possible values? Number of heads. How many? What are the possible values? The number of heads. What are the possible values my variable x can take? That's what I'm trying to tell you. This is the situation where my random variable will have no heads. It's a 0. These are the two situations in which my random variable will have exactly one head. 0, 1, and this is the only situation in which y random variable will have exactly two heads. So these are all possible values. I can have a 0 heads, 1 head, or 2 head. Now I ask you guys to pause this video and think about these. Like, these are now 3 problems of a probability distribution. The probability, like, what is the probability of getting exactly no head? What is the probability of getting 1 head? And what is the probability of getting 2 heads? Pause this video and think about the answer. So the probability that the coin will land 0 time, that the coin lands on head 0 time, is 1 out of 4, which is 0.25. The probability that exactly the coin will land exactly 1 time on heads is 2 out of 4, and that is equal to 0.5. And the probability that my coin will land on heads 2 times is again 1 out of 4, which is equal to 0.25. So my dear student, I have just created this beautiful table. Look at this table. Look at this table. This table is actually what is called a probability distribution. This table is just called a probability distribution. So it's a description. Look at this word, a description. A description. It's a description. A probability distribution is a description that gives you the values of the random variable. These are the values of the random variable along with their corresponding probabilities, right? Such a description is called a probability distribution. So now we see under what condition we will have a valid probability distribution. What are the requirements? What are the requirements? There are basically 3 requirements. The first one is we must have there is a numerical random variable x and its values are associated with the corresponding probability. The second one is the sum of all probabilities must be 1, and the third one is each probability must have a value between 0 and 1 inclusive. What I mean by that there is a random variable x and its values are associated with probabilities, like this one. We already seen in the previous table. The sum of all probabilities must be equal to 1, like this one. Sum of all probabilities must be equal to 1. And the third one is each probability value is between 0 and 1. Each probability value is between 0 and 1 inclusive. Now the question that comes to the mind, okay, professor, anybody comes and write a table on a board, will it be a probability distribution? The answer is no. We need to check these conditions. Let's see what I mean by that. Look at this table. I ask you to pause this video and think about it. Is this a probability distribution or not? Think about it and think about this one also. The second, pause this video and think about, are these 2 tables are representing a probability distribution or not? Pause this video and think about it. So you must have seen that this table is not a probability distribution. The reason is the sum of all probabilities is not equal to 1. The sum of all these probabilities is not equal to 1. If you add all these values, it doesn't come out to be exactly equal to 1. It has to be exactly equal to 1. Let me correct here. And what else we have here? And this is why this is not a probability distribution, due to this one. We don't allow a negative probability. We don't allow a negative probability. So the sum of all probability must be we don't allow a negative probability, right? For this reason, this is not a probability distribution. This is not a probability distribution because the sum is not equal to 1. And this is not a probability distribution because we have a negative probability. I hope you understand this. Thanks for watching.